Hey YouTube, XCT here. This video is all about escalating privileges on client 04. I figured it's best to make a video just on this, as it's fairly difficult to get it right and touches on some nice concepts. Alright, let's get started. So I'm back on client 04 here, and if we have a look at the users directory, we can see that there's Paula Perry and Linda Perry. Linda we already know like from the very beginning of this environment. And there's also Sally O'Connor. We don't know anything about this user yet. So let's have a bit of a look here in Bloodhound to see what this user can do. So if I look for Sally here, I marked her as owned, even though we don't have her owned yet, just to like enable some queries I want to do. So let's see. One thing I always check is like if you go to outbound object control, transitive object control, and now we can like see the group memberships and maybe what kind of things these affect, right? Domain users, not interesting. Service account managers, pretty interesting, but it doesn't like show the link where this is going. What else do we have? IT. Well, I guess many people are on IT, so this is not that special. And also certificate managers. This one is also pretty interesting. And it's even showing us that this group has write DACL on Shinra code signing. So maybe there's an ADCS attack we could perform here if we get control over this user. So let's go to analysis, and then we can just basically check for these misconfigurations. We had this in the enumerate video before. And if we do shortest paths to vulnerable certificate template access control from own principles, damn, that's long. And remember, we marked Sally as owned. We can basically see the attack path that's being laid out here. Sally is in certificate managers, and certificate managers have control over Shinra code signing. They can change the owner, they can change the permissions, and they can add properties. And this is something we can exploit later on. I'm not going into too much detail now, but it's going to be an interesting attack. The other thing we saw was service account managers. Let's see if this group has anything interesting here. In outbound object control here, we can see that this group is able to read the GMSA password of this service account. So this is a group managed service account, basically has a password that's managed by Active Directory. It's changed every 30 days, and this group can read the password. So that's another attack path from Sally that will get us further along into the network. Just from looking at Bloodhound here, we can see that Sally is probably a target that's worth pursuing. And well, how do we get access to the user? Either we find something on the system or we escalate privileges and then look for things like hashes or DPAP stuff or something like that, right? So let's continue looking around a bit on the machine. Do we have here? There's a tools directory, and inside we have signtool.exe. If this is actually the sign tool from Windows, that's pretty interesting. Because maybe this implies that some of the users on the box actually needed to sign stuff. Let's continue. Let's go to program data here, have a look here. Some interesting things. There's Chocolati, which is basically like a package manager. You can use it to install software. Well, OneDrive is default now with Windows. There's a policies directory. We've seen something like this before. So let's check that one out. And yeah, here we have another Windows Defender application control policy, the binary form here and the XML as well. So let's have a look here. All right, this is also like on the last machine, signed and reputable. So this was basically based on these default rules, right? The wizard was used again, and then probably the admin added something. So let's have a look through this file. All right, towards the middle here, we can see signature rules. This is pretty interesting. Let's scroll up a bit more. And if we go to signers here, we can see that Connor Brown is actually allowed to sign payloads. For some reason, it's in here twice, but it doesn't really matter. The fact remains that Connor Brown is basically someone that's trusted for signing. And if you remember, we already have control over Connor Brown because on client 03, we were in this user context, right? So maybe there's either a certificate on this machine, which we didn't see before, or maybe we are able to request one from the domain CA. Let's keep this in mind. This might be a viable bypass of Windows Defender Application Control. All right, and if we go to file rules here, we can see it's pretty much the same thing as on the other machine. Program files is trusted, System32 is trusted, but we're not an administrator, right? So on the last box, we could just place the payload in System32, but now we are not an administrator, so this won't be possible. But also there's one more rule here, which is the Windows directory, and there's service.exe. That's pretty interesting, looks non-default, so let's keep this in mind as well. Okay, this file actually does exist, so let's try to copy this over to our machine, just like this. All right, we got the file, so we can like try to analyze it. But we don't really know in which context this is used, but it's called service, right? So there might be a service that's actually using this binary to run. And if we go to program data here, we can see service is also a folder here, right? So let's go there. Let's go to logs. And then we can see a couple of log files. These always look like log underscore and then the date. So for today it would be 27. So this one actually. And if we read it, there's nothing too interesting in here. It's just basically writing some log that is still alive every 5 seconds. Yeah. Okay, interesting. So the service is maybe writing here. Let's also like check the permissions of this folder. And we can see that all users have full access to this. This is pretty interesting. So if there's actually a service writing to this folder and the service is running with certain permissions that are not like low privileged, and we have control over the folder, we might be able to do something. But we will check this out later. For now, this is just basically gathering information on the machine. And next, we're going to analyze the service to like get a better picture of what it's actually doing. All right, let's analyze the service a bit. I opened it here in the nspy, and we can see, okay, that's not too interesting here. Just initialization, project installer. But if we go to service here, that's like the main class, we can actually see some things here. So let's start from the bottom actually. It's initializing, it has a timer, so that's probably somehow related to the messages we saw. And there's a write to file function here. And basically this is called the message. And then it has a hard-coded path to the directory we just saw. And it's creating a file there, log underscore and then the day. Exactly what we just saw, right? It's basically writing there. Let's see. This is pretty interesting. There is grant access being called here. So what is this method actually? Grant access. We can see that some security rules are set on the file. So let's see what's actually being done here. File system access rule. And then it's setting a security identifier. Well-known SID type .wordSID. This is essentially everyone. And file system writes full control. This sounds dangerous, right? It looks like this is actually setting full control for everyone on the file. You might wonder, like, what's the implication of that? It's just a log file and program data. What do the permissions actually matter? But we will see in a bit that this indeed matters and is very dangerous. Other than that, we can just see it's basically logging stuff, right? It's creating these alive messages. It's making one when it stopped and one when it started. All right, so we got a pretty good idea what the service is doing. Not an awful lot. It's just logging stuff and setting basically this security descriptor on the log file. Okay, so the next thing I want to check is which permissions this service is actually running with. So how can we find this? Well, the easy way or straightforward way would be to do a rec query and then on current control set services. But this output is very long and we don't really know what the service is called, right? Could be anything. So this is not really viable. Instead, what we can do is we can basically search through the registry for our service.exe file because we already know how the binary is called, right? So let's do rec query on current control set services, search for the file for the string service.exe, and this is basically recursive. So it will find everything that has service.exe in it. And the list is a bit shorter here, right? Doesn't look like it's anything of the things we're looking for. Let's just run that again. Yeah, there was some output problem, right? Now we get the full list. And this is exactly the path we've been looking for, right? It's Windows service.exe. So the service is called custom service. And now that we know that, we can query this service specifically to find out with which user it's running. So let's do a rec query on this specific service. And now we see it's running as local system. So this is how you can like figure out from the command line with which permissions the service is running as. All right, let's look at the basic idea here. If we go to service, we saw the logs file here, and it's writing these and setting permissions on them. Let's say we somehow manage to make like a symlink from this file to a location that's more interesting. Let's say we link this file to system32 and write a DLL. That would be cool, right? Unfortunately, it's not that easy, but it's possible, and we're going to explore how it's done. Okay, so there's this very nice blog post here by Almond Security. Everyone that's asking me about the topic, I always refer them to this post. It's explaining basically how we can exploit privileged file operations like we have on our hands right now. First, there's some example on how to find these kind of bugs. We already have that, so I'm just going to skip over that. How to find them with procmon. Basically, you can just monitor interesting directories and then look for files that get created in them, right? And you can also like filter for the binary that you're interested in. So let's go for exploitation. There are a couple of things that are important. First of all, something like NTFS junctions exists. And these are basically like directory symlinks that you might know from Linux. Basically, you can symlink one directory to another, and this is allowed to be done from an unprivileged user. You don't need like any special privileges to do it. But if you think about it, that's not quite what we want, right? We could link logs to system32 if we want to write there, but it would still create the log_date.txt file. So this is not going to help, at least not just by itself. There's also something called hard links. Yeah, I can't really say too much about these because I have never like played with them. But in our situation, they're also not going to help. And now the amazing thing are object manager symbolic links. So basically we combine NTFS junctions with the object manager symbolic links. So the thing is basically that symlinks can only be created by privileged users. In fact, only by administrators by default on Windows, because you need the SE create symbolic link privilege. However, there are some exceptions, and one of them is RPC control. So every unprivileged user is allowed to create object manager symbolic links, for example, in RPC control. So this is like a special location where this only administrators thing isn't like applied. Everyone can create symlinks here. So what we can do is basically create a symlink in RPC control, because we are allowed, right? We can link from the log file to, I don't know, xct.dll in system32. That's possible, right? The only thing we have to do is also create an NTFS junction from the logs directory to RPC control, because that's also allowed, right? So we use this to go from the directory to RPC control and then redirect this to the final location where we want to write the file. And this kind of technique was often like exploited in the last years, many times with like AV products, because it's often overlooked, right? In program data, you often, due to inheritance, have permissions to like rename folders or delete them or change them. And if privileged file operations right there, you can use this trick to like redirect the file right. In some cases, you end up with a file that you can't change the contents of. But in our case, we saw that it's explicitly setting the permissions on the file, right? The end result will be set to full control everyone, so we can like change the contents however we want. Okay, so one thing that's left though is what do we actually want to write? What's the payload, right? Let's say we can create a file anywhere on the system with contents we control, which kind of file we want to place, right? One thing you can use is the Windows Error Reporting Manager trigger. This basically requires to place phoneinfo.dll in system32, and then you put a crash report into the directory for crash reports and basically run a scheduled task. And since the Windows Error Reporting Manager is basically loading this DLL, but it doesn't exist by default, you can execute your own code. This is one way to do it. Another would be spool trigger. This basically needs yet another file in another directory and will also basically load it if you run the script from the repository, right? And there are many things like this. Some still work, some worked in the past, and this is all good. But we're actually going to go a bit of a different route. Because remember, how are we connected to this machine in the first place? Well, we used SSH, right? And how would you like connect with an administrator to SSH on Windows? The authorized keys file would be the thing on Linux, right? It's the same on Windows really, except for administrators. It's a bit different because you don't have like a .ssh folder in the administrator's home directory. Instead, in program data SSH, there has to be a file here called administrators authorized keys. And this one is actually used by default to like find the public key of the admin. Let's actually check that here. If we go to sshd config, you can see that at the end here. That's the default, I didn't change that. Program data, SSH, administrators, authorized keys. This file needs specific permissions, basically. And if they only like are a bit different, it won't work anymore. You will get an error connecting with SSH. So we also have to fix the permissions. So to create these object manager symbolic links, we can use this repository here. Basically, there are two ways to do it. There's the excellent symbolic link testing tools by James Forshaw. And there's also SharpLink. And we are going to use SharpLink. That's basically just a C# implementation from Qtc. But it's very useful because we can use that in our own program, like as a library, right? And we can execute assembly the whole thing. So we don't really have to worry about AV later on. So this is like a nice way to do it. Okay, let's look at the actual payload repository here. This is a very short program, just a few lines of code. Basically, I integrated SharpLink into this program, and then I patched some places because originally this would like ask you interactively if you want to create a link or what happens if the file already exists. I patched that out just so there are no interactive parts. I want to execute assembly it, and I don't want to wait for user input. Okay, so what's actually happening? This thing has one argument, which is just the path to hijack. So this will be the program data service logs and then the log file. And it's creating a symbolic link from this target path, which is the argument, to what's called DLL path here, but really it's the SSH key. So it's basically just linking from the log file directly to program data SSH administrator authorized keys, but basically over the RPC control directory. And the only thing we have to do here is calling s.open. S is basically the object from SharpLink. Then we wait a bit. Why the sleep? Well, we saw that the program is writing every 5 seconds, right? So if we wait 10, it's safe to say that it's written at least once and change the permissions. Then we close the symlink, so everything is cleaned up again. And then this file should be created, this authorized keys file, and we should have permissions over it. So at this point, we can write our payload to it. And like I said, the only thing left to do is fix the permissions because it needs exactly two basically users that have permissions. One of them is system and one of them is the administrators group. And basically what I'm doing is I'm disabling inheritance and then grant administrators full access and grant system full access. And I also remove everyone because it only needs these two exactly, right? Yeah, all you have to do is basically compile this, copy it over, and then we should be able to execute assembly it. Okay, so just one problem at this point. We don't have a beacon on this machine yet, right? And there's still WDAC that we haven't bypassed. So remember the certificate thing, right? We wanted to check if there's like a key on the machine we compromised earlier. So let's connect there as Connor Brown again with WinRAM. And then let's go actually to the certificate store here and then just do an ls. And we can see that there's indeed a certificate in the personal certificate store of Connor Brown on client of Re. So we don't really have to create a new one. You could do it as well, right? But we can also use this certificate here. So how are we actually going to use it for signing? Well, we have to export it. And the first step to do that is to create a password that we can use, because you're only allowed to export it with a password set. Now the actual export command, get child item, that's the thumbprint here, right? It's the same value. And then we pipe it to export PFX certificate, give it the path we want to store it, which is in this case Windows tasks, and the password we created here, right? All right, we got the file. So this is now actually the exported certificate with the private key that we can use for signing. All right, now we got the file on our machine and we can upload it to client 04, right? So let's just use the tools directory here. And we can use the sign tool that's on the machine. You could also sign this completely offline on your own Windows VM if you like to. It's just easier because the sign tool is already here, right? So what we need is the certificate and also our beacon binary, right? So let's get the certificate here. Oh, of course, we need to be in PowerShell. Then let's get the beacon. Our listener's also running. That's good. And now let's run sign tool, just like this. So what are we doing? Sign tool, sign. Then we tell it the hash type. That's actually important because that's like the requirement to have a certain level of hash. So you can't use like MD5 or something if you want to do code signing. So keep that in mind. Then we give it the cert file, the password we had on export, and the binary we want to sign, which is our beacon. All right, it says it's successful. So let's check the signature. And it's saying that the signature is valid. So just to summarize, why is this working? We got the certificate from another machine. Well, the certificate is actually from the Shinra domain CA, and all of the machines are trusting it. So if we grab the valid certificate from client 03, we can also use it on client 04 or really on any other domain machine if we want to, because they all trust the CA. All right, let's now run the beacon. And this gave some output, so it didn't get blocked by WDAC. And we actually get the beacon here. For the sake of the video, we are again going to make it interactive. And then we can actually get to the point of running our file redirection exploit to write the authorized keys file. I already moved the file we just compiled, the C# program, to my Kali machine. So now let's just do the execute assembly. So I called it update.exe. And we are going to run it on program data service logs and the actual day, which today is 27th. Let's do that and see what happens. This doesn't look too bad. Let's go for the output a bit. It's linking from the log file to authorized keys. All right, we wanted to do that. To do so, it's first creating an NTFS junction from service logs to RPC control, and it's then creating a symlink from RPC control, log, and the file name to the final destination. And afterwards, it's just removing both of them again. And if everything went well, we actually get administrator's authorized keys here. Let's see if we can read the file, and we shouldn't actually be able to do it. And yeah, we get an access denied. That's actually good because we removed everyone again, right? We can actually not even like list the permissions because we have no permission whatsoever on the file. But the size looks pretty good. I think our key was written. So let's try to use Paula's key. Remember, we written her public key to the file on client 04 and hope that it works. And yeah, we are actually administrator just by writing the key file without like running any exploits. And now if we like go to the desktop, we will be able to get the flag here. So now that we got admin, what's our goal really? We wanted to get to Sally, right? So let's go back to tools here and let's actually get a beacon now as administrator as well. All right, here we have our session. And now we basically want to dump stuff and see if there's anything for Sally O'Connor, right? First of all, I want to do sharp DP API. So let's do that like this. Sharp DP API machine triage. And this is sort of running, but not really yielding a result. I'm not 100% sure why this is the case, but I believe that Elastic's behavior monitoring is actually blocking this at some point, so we don't get like the full output. Just to like give a small spoiler, actually there's a scheduled task here by Sally, and Sharp DP API should be able to see it and dump it with this command. It's not working, however, so I think Elastic is doing something here. And also, like if you look at the detections, you will see that behavior monitoring is actually killing this. So what else can we really do here? We still need this basically. So one thing that's built in Sliver as well, besides Sharp DP API, is nanodump. And this will allow us to dump the ELSAS process. So let's do that. First of all, we will need like the process ID of ELSAS, right? It's 692 here. So let's do it like this. Nanodump process ID, where we want to save the dump, and go. All right, this looks to be successful. Let's see. Okay, our dump file is here. Downloading the dump with SCP here. And it's even killed our beacon now. So Elastic really wasn't too happy with what we've been doing here. But let's get the command it's telling us to run here. So there's a lot of stuff here. Let's see. So what I was hoping for here is that in this output from nanodump, we would get the local administrator hash, because I'll need that for the next step. But for some reason, it wasn't in the output this time. But it's also not really a problem. We can also do something else to get the hash. It's a bit louder. We can, for example, since we are administrator, right, we can just do rec save to save a sum, and also do the same for system, and then get the administrator hash, the local administrator hash, right, this way. It's not very stealthy though. All right, and now we just gotta SCP them over. Then we can use PiperCats again, this time like this. And here we actually get the administrator hash. So I'm not sure why it wasn't a nanodump, but this also works for us, right? All right. And now, why did I even bother like getting the administrator hash? We already have like our key edit, right? What I want to use is something called Don API. And this is a really cool project, which basically is also dumping the credentials that are protected by DP API, by just doing it remotely from Linux, and therefore evading AV detection. And basically what it needs to run are administrator credentials to a box. So we can just run it like it says here. And we should be able to get the DP API protected credentials. So let's try that. We run it like this. Proxy chains, of course. We give it the administrator hash, which we just covered here, and then connect it as administrator. Let's see. Oh yeah, I need to like do it like this. And it already got more than we got before, right? We see, for example, the clear text credential of Paula Perry here. And also, finally, we get the password from Sally Connor. This is exactly the thing we've been looking for. This is like a very cool way to actually get the DP API credentials. And with this, we will be able to proceed like in the next video in context of Sally, either through the Active Directory certificate service attack or through reading the group managed service account password. All right, that's it for this video. If you like this content, please consider subscribing on Patreon. You will also get access to the lab, so you can try out all of these attacks if you want to. So that's it from my side. Thank you and see you next time.